Hello, welcome to the lab of Physics 143, Physical Systems. In this lab, you will do experiments to settle and better understand some of the concepts and ideas studied in class. Also, you will work on and develop your experimental skills. Physics is an experimental science. We physicists want to understand nature to describe it. That is why, based on our observations, we develop models and theories to describe it. But these models have to be tested with experiments. Indeed, you can make a great model very beautiful and simple, but if it doesn't describe nature, if it doesn't pass the test of your experiments, that model, that theory is wrong or incomplete. In the lab, you are going to ask nature simple questions, and you are going to obtain answers to those questions. To do that, you will be given some lab equipment, and you will design some experiments. The better you design your experiment, the better and more reliable the answer you get from nature will be. Let's focus on the first lab, reaction time. Because time measurements are very relevant in mechanics, in this first contact with the lab, you are going to focus on time measurements. Imagine you want to become a brand new superhero called superphysics. As such, you need to be fast reacting to unforeseen situations. That is why you need to know very well what your reaction time is. That can be the difference between saving the planet or not from the supervillain. That will also tell you how good your experimental measurements are going to be when you use a stopwatch, for instance. This week, you are going to explore how much your reaction time affects time measurements. You and your partner will be given stopwatches, rulers, and balls. You have to think about an experiment that lets you measure your reaction time. For example, when something happens at a distance of 1,000 feet and you want to react to that, light travels and takes 1 microsecond to arrive to your eyes. Then the signal from your eyes has to go to your brain, and your brain has to send a signal to your muscles. How long does all this process last? This stopwatch has a resolution of 0.01 seconds. One important question is, can you trust all the digits? If your reaction time is smaller than 0.01 seconds, then you can trust all of them. But what if your reaction time is 0.05 or 0.1 or half a second? In the latter case, you are introducing an error to the measurement of plus or minus half a second. So you cannot speak with higher resolution than that. This means that the second decimal place has no sense. In physics, when you give a numerical result from an experiment, it has to be with the proper units, and it has to include the experimental error. For example, for a distance, this could be this, 0.02 plus and minus 0.02 meters. How you and your partner are going to measure your reaction time? Well, you could compare a well-known time interval and you could try to measure it. For example, your partner can run a stopwatch and say go when it reaches a number of seconds she has decided, let's say 10 seconds. Then she can say stop when it reaches another number of seconds she has decided, let's say 20 seconds. Do you think this would work? Probably you would be measuring a mixture of your reaction time and your partner's reaction time. Another way could be by dropping an object from a well-known distance and using the equations of kinematics you have already studied. For example, this one. If you know the distance and you know the gravity, you know the expected time of arrival. You can compare the expected value to the experimental value. Think about this method. Would it work? Another way could be having your partner drop a ruler from a well-defined height and having you catch the ruler. Think about these methods and others to measure your reaction time. Once you have decided how you are going to measure your reaction time, you should think about how many trials you want to do. Finally, you will decide how precise you can expect time measurements to be. In physics, there are different ways to share our results with the community. One of them is through presentations. This time, you will prepare a 5-minute presentation to share your findings to the class and answer questions from other groups. Make sure you write notes about your work as you proceed, and may the science be with you.